Okay, in this short video, I'm going to show you how to do a calculation based on an annuity. Firstly, I'd like to explain what an annuity is and also what a perpetuity is. An annuity is like an investment or maybe even a payment on a mortgage in which you actually receive an income or make payment by a fixed amount each year for a limited time period only. So say for example, if you took out a 20-year mortgage and your repayments are €1,000 per month, well, you know that over that 20-year period your repayments are going to end. Another example of an annuity is that if you were in receipt of an income like a pension or say some alternative investment in which you might have made, you sometime in your lifetime will receive income from that investment over a fixed period of time. A perpetuity, on the other hand, is like an annuity, except it's for an infinite period of time. So if it did exist, they don't really exist anymore, but if it did exist and you received an investment, you will receive a fixed amount every month or every year indefinitely or for an infinite period of time. And likewise, if you were to put a perpetuity on your mortgage, it means that you'll be forever paying your mortgage. So of the two, an annuity is the one that we will actually be looking at. Here's a formula for the question that we're going to be looking at, and in this video we're going to be looking at two questions. They're very similar to one another but just changing around so you can have an idea of how you might work with different numbers, that's all. So the present value of an annuity is given by this formula, and you are to find the value of X. Or is the interest rate, we'll assume it's fixed, and N is the number of years for that investment or borrowing period. So PV of an annuity, or the present value of an annuity, is equal to this formula. So for example, you're buying a house, you have a 20-year mortgage of $120,000 at 5% per annum, and you want to know what your monthly repayments are. So based on the formula that you've just looked at, I'll show it again after this slide, we see that the present value of this annuity is 120,000. And the reason why we know, by the way, that this is an annuity and not a perpetuity is that you have a finite period of 20 years. So the present value of that 20-year annuity is €120,000. That's going to be equal to the formula. And in that formula, or is your 5% or your 0.05, N is 20, and we need to find X. So that's your formula. We put the 120,000, which is the present value of the annuity, equal to all of that there. I've just highlighted them in red, black and blue so that we can see the transition or how we progress for each stage of this calculation. So let's concentrate on what's in brackets, what's in square brackets first. So we have the 1 divided by 1 plus 0.05 to the power of 20. Let's add the 1 and the 0.05 together and then get that to the power of 20. We'll get 2.6533. We divide that into 1. We get 0.37689. And then we can subtract it from your 1. 1 minus 0.37689 is going to give us 0.62311. Let's move that figure in blue over to the other side of the equal sign. So that square bracket 0.62311 is a multiple of what's in red. We bring it over to the other side and it becomes a divisor. So 120,000 divided by the 0.62311 is going to equal the remainder of that formula. And working through that, 192,582.37. What we'll do then is we need to get rid of the 0.05. That's part of the X, and that is a divisor into X. Bringing it over to the other side will become a multiple of. So that's why I have that 192,582 multiplied by 0.05 is because we brought that 0.05 over from the right side of the equation to the left side, or the right side of the equal sign to the left side, and that was a divisor. Now it's a multiple of. So we multiply that by 0.05 to get us a X of €9,629. And we were asked to find out what the monthly repayments are on this mortgage. This is the annual repayment. So to get the monthly repayment, we just divide it by the 12 months and we get €802.42. So if you want to pause the video at this point, just go back to the beginning, have a look through that again, and then you might be ready for the next question, which is very similar. So this came up in summer 2018, question 4D. A company negotiates a loan for €200,000, a 15-year period at 10.5% per annum. So we know this again is an annuity because we have a finite period of 15 years. We're asked to calculate the annual and monthly repayment necessary to amortize the debt. All that means is to cancel out the debt. Again, we have our formula. If you recall, what are these values? The 200,000 is the PV annuity. In other words, that's the present value what we're looking at now, the loan. We need to find the value of X in that formula. Or is your 10.5%. And N is 15. Okay, that's just confirming or repeating what I just said there. Plugging all those values into the formula, we have your present value of the annuity of 200,000. That's equal to X divided by your 0.105, which was, remember, your 10.5%. And again, I broke it all up into the colors there. So we're going to concentrate on what's in blue first. So 1 over 1 plus 0.105 to the power of 15. So 1.105 to the power of 15 gives us our 4.4713. We divide that into 1, 0.22365, and we'll take that away from the 1. We get 0.77635. Now we bring that 0.77635 to the left of the equal sign. It was a multiple, now it becomes a divisor into the 200,000. And we have what's left of that right side of the equation, X divided by 0.105. So concentrating on the left side now, 200,000 divided by the 0.77635 is going to give us 257,616. And then what we'll do is, with that 0.105 that's on the right side of that equation, it is a divisor into X. We bring that value over to the left side of the equal sign. It becomes a multiple of. So the 257,616 multiplied by the 0.105 will give us €27,049. That's the annual repayment necessary to amortize the debt or to cancel out the debt over that 15-year period. We want to get the monthly repayment as well, so we just divide that by the figure of 12 and we have €2,254 per month.